Okay, so the problem to be solved. I have, this is an ESP32 microcontroller module that I want to use for high altitude balloon tracking. This module, it takes is an 18250, I forget the number, standard LiPo battery here. And this module for 25 bucks from Banggood has a GPS on it. It has low RA, which is a radio, 100 milliwatt radio. It's got the microcontroller. It's got a ton of GPIO on it. It's got Bluetooth and it's got Wi-Fi. So all of that for about 25 bucks. So what I want to do, since I do high altitude balloon stuff, is make this do APRS as well. And so to do APRS, I've got some I've written some software, and I can use a clock chip called an SI5351B, and you can pump modulated output into that chip and mix it and basically transmit on 144 megahertz. So I can basically beacon APRS. But to do that, I need to basically add that chip to this thing. So what I want to do is add a riser board. So I designed a riser board. You can see the pins there for the riser. So I designed a riser board to sit on top that's going to have the extra functionality. So this board will add APRS. And actually, oh boy, there's the cat. We'll add APRS and also a barometer and temperature module to this microcontroller. So this tiny form factor becomes an APRS tracker with basically everything built in, just by adding that board. So that's the problem to be solved. So the problem is, how do you design this? Oh my God. As I said, this cat is an agent of chaos. He's knocking cameras around over there. Okay, so let me go to a different screen share here. I'm just going to share my whole screen. And so first thing I had to do is, make a schematic. So I'm not going to go into any detail here, but here's, stop griping at me, Twitter. Go away. Okay, so here's a schematic. Here's the main board, which has the clock chip, an oscillator, some LEDs. There's the headers that go on there. There's my temperature sensor, and then on here I have a couple of filters. Here's a low pass filter for the APRS. Cat keeps batting the camera over there, and an audio filter for the modulated output.
Oh no, he's making it sync.
This is all the circuits I put together. So now it's like, okay, I got to put this onto a board. Well, this circuit design, I'm using Diptrace here. It's called Diptrace. A lot of people use another program called Eagle. I started with Diptrace because the guy who sort of mentored me on this used Diptrace, and he thought it was easier than Eagle. Now that I've learned Diptrace, I don't know that it's any easier than Eagle. I think they're probably both about the same. Once you learn one of these tools, you can probably use any of them. And KiCad is another one that people use quite a bit. So, and KiCad's a totally open freeware version. So I may start moving myself to that. So here's the schematic. So from there, you run another program, which, whoopsie, you run another program, which will basically allow you to design the board. And wow, did this format poorly here. So here's my board layout, and the tool lets you, let me hide the copper pores are just a pain to look at. So I always hide the copper pore. There, I can see a little bit better. So you can design how big your board is. You can lay out all the parts, and then you basically draw the traces to connect the dots on your parts. And this is basically how I laid out the board. So and you can design both the front and the back. So some of the traces I couldn't manage, so I had to do a couple of traces on the back to connect things. So you can do that. You can put vias through and connect all the dots. So this is basically how you design the board. So now that I've got a board designed, it's like, well, okay, what do I do with I got a nice design in my computer. What do I do now, Lieutenant? Well, what you do then is you go online and you order the boards. And where I ordered them from is a place called OSH Park. And a lot of people use this company. And what you do is you can basically do a save as of your board design and save it as what's called a Gerber file. And the Gerber file basically lays out everything about the board, where the drill holes are, where the components sit, where the copper is, where the solder mask is, what you see in purple on there, where the silk screen is, where the lettering is. All of that is laid out in Gerber files. And basically you drag and drop the Gerber files into a utility on their website, and it shows you what the board would look like when they manufacture it. So this is what they said the board would look like based on the Gerber files I sent. And, you know, when you see the board on camera, it looks exactly like this. So you look it all over, you make sure it looks okay, and all the, you know, it meets all the build guidelines. And if you do that and everything's right, you can order the boards. And they require, OSH Park requires a minimum of 3 boards. And so I've got 3 boards, and it cost me about $13 shipped. So you submit the Gerbers over the web, and about 2 weeks later, you know, and $13 on your credit card, and about 2 weeks later, you get 3 boards in the mail. So that's how you get your board. And now I need a stencil too, because I don't want to try to paint solder onto each of these little spots. So there's another company, totally different company, that called themselves OSH Stencils. And they're basically exactly the same deal. You connect up to OSH Stencils on the website. You drag a Gerber file for your basically your solder mask and your drill holes to them, and they manufacture just a cheap plastic stencil. You can also get them made in stainless steel, stuff like that. So they made me a stencil for 1 board at a time. So I use the same stencil to do 3 boards, 1 at a time. And again, this was like 14 bucks. And they make the stencil and they ship it to you in the mail. And again, so you design everything, you send your Gerber files and give them your credit card, and about 2 weeks later, you get a stencil and you get some parts in the mail. And that's where our story begins tonight. So any questions about any of that?
What does the stencil do again?
So the stencil, I'll be showing you in a minute. Let me bring up my camera. Hey, Ellen. Let me reshare and put my camera back. All right, so here we are. So here are the boards that came in the mail. So there's my 3 boards I got, and you'll notice they look just like the boards that OSH Park said they were going to send. And there's the stencil. And what you do is you need to solder your parts onto the board. So basically what we're going to do is place the stencil over the board, and the stencil's got tiny little holes in it. And so you put some solder paste on here, and solder paste is sort of just what it sounds like. It's like the consistency of toothpaste. And then we're going to go like that, and then carefully peel the stencil off, and it's going to leave solder just on the copper pads where the parts need to sit. So that's the plan. But before we do that, there's a couple things I need to do.